Hello people, so in today's video we are going to talk about circle geometry, and while in that video we'll be looking at some exam questions from all the exam booklets, and we'll also review on some circle theorems, which is grade 9 topic. So let's begin. Right, this question is question 15 of 2022 exam booklet, and it says N and P are points on the circumference of a circle with center O. N and P are these 2 points on the circumference. O is the center of the circle, and Q is a straight line passing from one part of the circumference through the center or through the outside part of the circle. So NO is the radius, and to this part of the circle is the diameter, and it continues to point Q. And it says angle OQP. OQP, remember when we were naming angles, the letter in the middle is where the angle is formed. So this is this angle at point Q. Alright, the question is, what is the size of the angle marked X? And here is the angle at the center within this small triangle NOP. Alright, if we can recall our circle theorems from last year, grade 9. Oh, it's right here. Alright, this circle theorem says that the radius and a tangent, they meet at 90 degrees. The angle formed between a tangent to a circle, which is this line outside touching the circle at one point on the circumference. This tangent meets the radius, which is a line joining the center of the circle to the circumference. They make a right angle, 90 degrees. So this angle right here is 90. Let me mark it here. So this angle form is 90, and this angle is also 90. So based on this circle, based on this theorem, you can see the angle right here is that 90-degree angle formed between the radius OP and the tangent PQ. That's one of the theorem. You can use the theorem to first find this particular angle using the big triangle NQP, and then later you can find X using this smaller triangle. Or if you can remember that in a circle, all the radii, which is plural for radius, all the radius all around the circles, they are equal in length. You would have noticed that these two lines here, NO and OP, are radius. Okay, NO and OP are radius, radii. So they are equal, making triangle NOP an isosceles triangle. And in the properties of isosceles triangle, base angles, which are these two angles, they are equal. Therefore, angle NPO, this angle right here, is 29 degrees. Alright, and now we can use this smaller triangle NOP to find angle X right here. And so angle X is 180 minus 29 plus 29. Why? Because in a triangle, the angle sum is 180. Alright, so 180 minus 58, which comes from 29 plus 29, gives us 122. So the answer is B, right here. Let's move on. Now here are some some terms associated with circles in case you forgot. So this is a circle. A circle is a set of points, all of which are the same distance or equidistant from a given point. That's kind of describe the radius. When we connect all these points, we create a circle. The circumference is the connection of all these points which are equidistant away from the center. So this outside part is called the circumference. It's actually like the perimeter of the circle, but a circle is a unique shape, so it's given a unique name, circumference. And also it's kind of like going in a circle, and so we call it circumference. Okay, the circumference is calculated using this formula, pi d or 2 pi r, where d is the diameter and r is the radius of a circle. Okay, some other parts of a circle. The arc. Now the arc comes from the circumference, and we have a minor arc which is smaller in size and a major arc which is bigger in size. Those two are just parts of the circumference. A chord is a line joining 2 points on the circumference of the circle, and they do not pass through the center. Okay, they just connects 2 points on the circumference away from the center. And a chord divides the circle into 2 segments, which are parts of the circle. This is a minor segment because it's small, and this part here is the major segment. Okay, the diameter is also a chord, but it's a special one because it passes through the center of the circle, and so it is given a special name, diameter. Okay, and the diameter divides the circle into 2 equal segments, and they are called semicircle. Semi means half, so the diameter divides the whole circle into 2 half circles. Let's move on. The radius. A radius is a line connecting the center of the circle to the circumference. The plural is radii, and like I've said before, everywhere around the circle, the radius is, all the radii are the same. They are equidistant. Equi for equal, distance for distance. So all the radii are equidistant all around the circle. Okay. Now, sectors. If you draw 2 radii in a circle with some angle between them, they divide the circle into 2 sectors. Okay, don't confuse sectors with segments. Sectors are like when you are cutting a pizza or a circular cake, and to be fair to all the people that you are distributing the cake or the pizza to, you always cut through the center. Okay, so you are kind of cutting, or you are kind of creating diameters and radius as you cut the pizza to share to whoever you are sharing to. So sectors are kind of parts of a circular pizza, and they are formed by radii. So this here is a sector, and this part here is also a sector. This one is a smaller sector, so it's called a minor sector, and that one is the major sector. Okay, next, the tangent is a line outside of the circle which touches the circle at one point on the circumference. And what else? Okay, subtense. Subtense means holds up. Okay, what does it hold up? Oh, by the way, a submarine travels under water. So if they say the arc AB, this is the arc, subtends the angle APB, this is the angle APB, then it means the arc AB is under submarine, under water, marine for water, sub, under. So the arc AB is under the angle APB, and it kind of holds it up. Okay, so it holds up the angle. And we can describe this by saying the angles APB, and angle AOB also, AOB, stand on the minor arc AB. They are above the arc AB, and the arc AB is under is under them, so the arc kind of holds up these two angles. All right, let's continue. Next, we see the properties of circles, which are theorems. Angle in a semicircle. So if you see a diameter and you see a triangle forming inside one of the semicircles, then the angle in a semicircle is a right angle. Now, which angle exactly? We have three angles formed in a triangle. This one at the point A, this one at point B, and this one at point P. Okay, the angle that is 90 degrees is angle APB. That's this one. APB, that's the angle on the circumference. Okay. The other theorem is chord of a circle, and remember, a chord is a line drawn from one circumference of a circle. A chord is a line drawn from one point on the circumference of a circle to the other. So in this diagram, AB is a chord. AB is a chord. And it says a line drawn from the center of a circle perpendicular to a chord. This is the line we're talking about. OM from the center of the circle, perpendicular, which means it forms a 90-degree angle with the chord. It bisects the chord. Bisects means it cuts the chord into two. Bi means two. So it bisects the chord AB into two equal parts. So we can add some symbols here to show that they are equal to stroke to stroke. Okay, so AM, the length of AM is equal or same as the length of BM. And then we have chord of a circle, which is the same theorem as this one, but we look at it the other way. If a line drawn from the center of a circle to the midpoint of a chord, midpoint, so it means right here is the midpoint of the chord AB, and midpoint means the other part is equal to the other part. So a line drawn from the center of a circle to the midpoint of a chord is perpendicular to that chord. Alright, at this part, they told us that the line from the center is perpendicular. It forms the angle. And so if we see the 90-degree angle, then we will know that it divides the chord AB into two equal parts. So AM is equals to MB. Now they give us the chord AB, and they say they are the chord AB is divided into two equal parts by this line from the center. And so by seeing this property here that these two lines are equal, the chord here is divided into two equal parts shown by these strokes, then we will know that the angle formed between the line from the center meeting the chord, the angle here, will be 90 degrees. Okay, 90 degrees. Same property, chord of a circle, but here they gave us one condition and we use it to find the other condition. Here they did go the opposite. They gave us the information that this chord is divided into two equal parts. So using this information, we are going to work out that the angle formed between the line OM and the chord AB is 90. Same theorem. Next one, radius and tangent. Okay, the radius, line from the center to the circumference, meets the tangent, the line on the outside touching the circumference at one point. They meet at 90 degrees. Next theorem, tangents from an external point. Now we have two tangents coming from the outside and touching the same circle. And the theorem is the two tangents drawn from an external point to a circle are equal in length. Okay, they are equal in length. So PA is equal to PB, and we can use this property to help us find angles. Tangents from an external point, that's the same theorem, but now it's extended a little bit. The two tangents drawn from an external point to a circle are equally inclined to the line joining the external point to the center. This is the line to the center. Okay, equally inclined. Inclined talks about the formation of angles. Like incline means kind of the line is a bit, OP kind of looks like a straight horizontal line. At BP, it kind of forms an angle by sloping upwards, and PA is kind of sloping downwards, so they form equal angles. And here it is, angle OPA. OPA, this angle, is equal to angle OPB. OPB. Right there. So these two angles are equal. So let's say if angle BPO, this angle right here, is 30 degrees, then this angle OPA is also 30 degrees. 30 degrees. Yeah, my circle looks like a... Okay, anyways, you get the point, right? Let's move on. Continuing with the theorems. Angle at the center of a circle. So the angle at the center of a circle is twice the angle at the circumference subtended. Here's the word again. Subtended by the same arc. The arc is AB, and it's subtending, meaning it holds up, it lies below this angle AOB and angle APB. So what's the relation between those two since they are held up by the same arc? Well, angle AOB, the one at the center, is 2 times the angle at the circumference. You can see by the look of the angle, this one is a bit wider than the one at the circumference right there, and the one at the center is exactly 2 times the angle at the circumference. So let's say if angle P is 20 degrees, my circle, then what will be the size of angle AOB? Well, it will be 2 times 20 degrees, so it will be 40. Please, 40. Can you come good? Please, I cannot write with this thing. Okay, you got the point, right? And then we have this angle subtended by the same arc. Now we have more than one angle, and they are again held up by the same arc, and take note they are touching the circumference. Angle Q, angle P, angle R, they all come from the same arc AB. Take note, the lines that form the angles, they start from the same arc. Okay, one line comes from point A, the other line comes from point B. For angle P, one line comes from point A, the other one comes from point B. Same as angle R. So that means all these 3 angles on the circumference are not anywhere inside the circle or outside the circle. How are they related? They are all equal. They're all equal. Then we have this one, which is the same as that, and this one same as that. Okay, the angle between a tangent and a chord. Tangent and chord. Tangent and chord. These 3 are all chords. B, C, C, A, B, A. They are all chords because they connect 2 points on the circumference of this circle. SAT is a tangent. Okay. They form angles. The angle between a tangent and a chord could be this angle, angle CAT, or this angle, angle SAB. How are they related? The angle between a tangent and a chord at their point of contact right here is equal to the angle subtended held up by the chord in the alternate, which means opposite segment. Let's go over it again. This angle formed between a chord and a tangent is equal to the angle held up by the chord in the alternate segment. Remember, as a segment is formed by a chord which connects 2 points on the circumference, we have a minor segment and a major segment. So let's go back there. So this chord CA divides the circle into this minor segment here. The green segment is minor and the blue segment is the major segment. So it is said here, the angle between the tangent and the chord, if we look at this angle, angle CAT right here in the green part, is equal to the angle subtended held up by the chord in the other segment. Okay, so if you look at line CA, then it divides the circle into the green segment and the blue segment. So they say this angle in the green segment is equal to the angle subtended by the same chord CA in the other segment. They're talking about this angle. So if this angle in the smaller segment is 30, pardon my elementary style writing, then this angle CAB is also 30 degrees. Okay, so now we will look at some exam questions which are related to circles. And here's the first one. This question is from the 2000 exam paper. It says here in the triangle, O is the center of the circle, PR is a tangent, PR, and angle MNR, MNR. The angle is formed in the middle letter is 66 degrees, and the question is find the size of angle MON. MON, which is this angle right here. This is the angle at the center. Okay, so if you look at it, we have a radius and a tangent. So they will form a 90-degree angle. Let's go back. Radius and a tangent right there. The radius and a tangent forms a 90-degree angle. So this full angle between the radius ON and the tangent RNP is 90. This full angle is 90. Now if part of it is 66, then this other part, which is inside the triangle, t minus 66, which gives us 10 minus 6 is 4, and 8 minus 6 is 2, 24. Yeah. Okay. So this angle right here is 24, which is inside the triangle. 24. Come on. Alright, and then we look at this triangle MON and take note. The radius MO and ON are equal in size, equidistant, which make triangle MON an isosceles triangle, so the base angles are equal. So this angle at the point M is also 24 degrees. 24 degrees. And now we can find angle MON, this angle right here, by subtracting these two base angles from 180. Let's see if I can write nicely. So 180 is the angle sum in a triangle minus the two angles that are known already, 24 plus 24, so it's 132 degrees. Pardon my writing, sorry, it's my first time to use this tool. Moving on, Now here I have some questions for you to practice. 1, 2, 3, 4. I have 4 questions here. You put the video on pause and you try them out. And after you have tried them out, here are the solutions. So in the first question, it says triangle ABC is inscribed, meaning it is drawn inside a circle with a tangent at point B. The tangent joins the circle at point B. If chord AB is 12 and chord BC is 5, work out the value of diameter AC. Okay, so AB is 12, BC is 5, and they ask us to find the length of the diameter AC. Okay, from the circle theorem of semicircle, where an angle formed inside a semicircle is 90, we use this property to show us that the triangle ABC is a nice right angle triangle. And so this side, which is opposite to the 90 degree, is the hypotenuse. And so we use the Pythagoras theorem. The square of the hypotenuse, AC squared, is equals to the sum of the square of the two shorter sides, or short side squared, AB squared, plus BC squared, the other short side squared. So AB is 12, square it. BC is 5, square it. So AC squared is equals to 12 squared plus 5 squared. And 12 squared is 12 times 12, which is 144. 5 squared is 25. And when we add them up, we get 169. And the square root of 169 is 13, not 14. 13 cm. Alright, next question. The composite shape below is made up of 2 shapes. One is a rectangle and one is half of a circle, a semicircle. Use the information provided to answer the questions that follow. So we have the width of the rectangle, 14 cm. The length, it's not the length of the rectangle, it's the length of the whole shape, 49 centimeter. Pi is 22/7, and area is pi r squared. This is the formula for the area of a circle, full circle. The circumference is equals to 2 pi r, or pi d. That's the formula to find the circumference. Okay, part 1. Name the unshaded shape. Okay, this is the shaded part, and this is the unshaded part. So they are saying name the unshaded shape that makes up the composite shape, and it's a semicircle. Okay, semicircle. Part 2. What is the value of r? Okay, the same shape is shown over here. So as you can see, the full length of the composite shape is 49 centimeter, and the width is 14 centimeter. Take note, in a rectangle, opposite sides are equal, so this side is equal to this side, which means from here to here it's also 14 centimeter. So half of it, which makes up the radius of the semicircle, is 7. Okay, the radius is half of the width of the rectangle, half of 14, which is 7. Okay, this radius is the same length as this radius, since all the radii are equidistant from the center of the circle to the circumference. So the radius here, which is from this point to this point, is 7. Question 3 says find the area of the unshaded region. The unshaded region is the semicircle here. Question 3 is here. Since the unshaded region is a semicircle, we go pi r squared, which is the area of a full circle, times half, or divide by 2. And they said to use pi as 22/7. R is 7, so 7 squared times half. Now, I want you to not calculate 7 squared and write 49 yet. I want you to write it as 7 times 7 with the aim of cancelling out this denominator of 7, because division is a little bit difficult compared to multiplication. So, write 7 squared out as 7 times 7, and then we'll cancel one of them with the 7 in the denominator. And before you multiply and get big numbers and then you struggle to divide, you simplify first. We can simplify this 2 with this 22. Well, 2 into 2 goes 1, and 22 into 2 goes 11. So now we are left with 11 times 1 times 7 times 1, which is 77 square centimeters for the area of the semicircle, unshaded part of the composite shape. And question 4, find the area of the shaded region, which is the rectangle. So, from working out the radius of the circle, we now find out that from this bit to this bit is 7, since it is exactly the same as the radius of the semicircle. So the length of the rectangle is 49 minus 7, because the length only stops here. So 49 minus 7, which is 42. So the area of the rectangle is length times width, which is 42 times 14. Okay, you can do your normal calculation. I'm just showing you an easier way without using a calculator. You break 42 up into 40 plus 2 and 14 up into 10 plus 4, and we expand like how we do quadratic equations. So 40 times 10 is 400, 2 times 10 is 20, 40 times 4 is 160. Oh, where did I go? 2 times 4 is 8, and 40 times 4 is 160, and when we add all of this up, we get an area of 588 square centimeters. Let's go to the next question. The diagram shows a circle with tangent RS and radius OR. What is the value of angle X? Alright, so remember that a radius creates a 90-degree angle with a tangent. Here it is, that's the 90-degree angle. So one angle in the triangle is already found. Now this angle is 105 degrees, and it forms a straight line angle with the other angle inside the triangle, ROS. And so we use this property to find the angle inside the triangle at point O. So 180 minus 105 is the recent angles on a straight line. It gives us 75 degrees. So now we have two angles known inside the triangle ROS, and we can use it to find angle X. Angle X is 180 minus 90 plus 75, y 180. Well, that's the angle sum in a triangle. 90 plus 75 is 165, so 180 minus 165 is 15 degrees. And a reminder again, if they do not give you the units, please write the units. Last question. In the given circle, diameter LM, diameter, meets the tangent XY, and O is the center of the circle. Find angle MLY. MLY. Well, that is simply the angle between a radius and a tangent. By the way, ML is the diameter, however part of it, OL, is the radius. So here is simply the angle formed between a radius and a tangent, which is simply 90 degrees. Okay? Okay, warning. All this information's right here, 31 degrees and 62 degrees, they are just distractors. If you do not memorize your theorems, your circle theorems, you might think that these are important, and then you might go and calculate this and then that and that, which is a waste of time. So memorize your circle theorems and use them to make your life easier in the exam room. That's the end of today's video. Hope to see you soon in the next one. And subscribe and like, and please make some comments there so I can work on fixing some things that are not cool at the moment. Alright, bye for now. See you in the next one.